Hello and welcome to our channel. So today we'll be doing the question paper that was written in 2018 by the grade 10s, and we'll be doing analytical geometry, trigonometry, trigonometric functions, measurements, and Euclidean geometry. So let's start with our question 2. In the diagram below, P1 and 0, 6 and 3, that is Q, 9 and negative 2, that is R, are the vertices of a triangle such that PQ is equals to QR. So the first thing that they tell us is that this line, which is PQ, is equals to the line that is QR. And then we continue. And PQ is perpendicular to QR. As we can see, there's a 90 degrees angle there. T is a point on PQ such that T is the midpoint of PQ. So they tell us that T is the midpoint of PQ, meaning PT is equals to TQ. And then S is the point of intersection of the RQ and the x-axis. As we can see, this is where it cuts the x-axis. V is a point on the x-axis such that Q angle SV is equals to 121, as we can see, and they say Q angle PS is equals to theta. So the first one says determine the length of PQ and leave your answer in said form. So we do know that the distance is equals to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we'll take Q as 2 and we'll take P as 1. So the distance of PQ is equals to the square root of what is the x of Q, that is 6, minus the x of P, which is 1. And then you square that plus the y of Q, which is 3, minus the y of P, which is 0. And then we square that. And then you just punch this on your calculator, you get the answer. And you write it down. So the square root of into 5, which is 6 minus 1 squared, plus it's 3 squared. And then it gives us the square root of 34. So this gives us the square root of 34 units, since it's the distance. Now we do know that this is root 34. We also know that this is the same distance, which is root 34, which we were given here. And also this one will be half of this. So that means it's going to be root 34 over 2. Even this one, root 34 over 2, since T is the midpoint of PQ. So that means it cuts it into equal distances. And then we move to number 2, 2.1.2. It says determine the gradient of PQ. Now we do know the gradient is equals to the change in y, which will be yq minus yp all over xq minus xp. So the gradient for this line, which is PQ, is going to be 3 minus 0, all that is over 6 minus 1, which is the same as 3 over 5. And then we go to 2.1.3. It says the coordinates of T. So T is the midpoint, and we do know that the midpoint is equals to x1 plus x2, all that is over 2. And for the y value, you just say yp plus yq, and all that is over 2. So we can now calculate the coordinates of T, which will be 6 plus 1 over 2 and 3 plus 0 over 2. And that gives us the coordinates of T as 7 over 2 and 3 over 2, and that is the coordinates of t. Now we go to 2.2. The first one says find the area of QTR. Now we know that QTR is already a right angle triangle, so we just need the base and we need the height, and we already have the distances for these two. So that means the area is equals to half the base, and the base we can just say it's QT multiplied by the perpendicular height, which in this case it's QR, and then the area is equals to half of what is QT, it's root 34 over 2, and then what is QR, that is root 34. I believe this will give us 34. So let me just punch that on your calculator real quick. So that's half into root 34 over 2 into root 34, and yes, it does give us 17 over 2. So we've got 17 over 2. So the area is equals to 17 over 2, which is the same as 8,5. Then we say square units, because we do not know the units here, whether they were centimeters or whatever they were. And then we move. We want now the size of theta, and they say with reasons. So we can see that theta is that angle there. Now if that is what theta is, we can now say let's look at this triangle, which is PQS. Now when we look at that triangle there, we can see that we've got an exterior angle of a triangle, and that exterior angle of a triangle is equals to 121. Now since we have that 121, we know that the exterior angle of a triangle is equals to the sum of the opposite interior angles. So this one is theta, this one is 90, so we do know them. Now we can just say theta plus 90 equals 121 degrees, and then the reason is the exterior angle of a triangle. And then we say that theta is equals to 121 minus 90 degrees, which will give us 31 degrees, which obviously makes sense that it's an acute angle. And then also you can calculate this using the gradient of PQ, since you already know the gradient of PQ here, that it's 3 over 5, and we also know that M is equals to tan theta. That means theta is gonna be what? Now let's just substitute the value of M there and see which angle we get. So that is 3 over 5. Now when we punch that on our calculator, we are going to get 30,96. So it's 30,96 degrees. And obviously, as you can see, if you were to round this off to the nearest whole number, it will give you the same value, which is 31. And then now they say calculate the coordinates of S. Now when we look at the coordinates of S, we can see that S is actually the y-intercept, or the x-intercept rather, of this line, which is QR. Now looking at QR, we can see that since we do have the coordinates, we can find the gradient, and we can also use the equation y is equals to mx plus c to solve for the value of c, and then we write the equation and then we solve for the x-intercept by letting y be equals to 0. Now since we know that the gradient of PQ is 3 over 5, That means the gradient of QR is going to be negative 5/3, which is the negative reciprocal, since we do know that they are perpendicular to each other. So that is where we can actually start finding the gradient of QR, which is negative 5/3, and the reason is PQ is perpendicular to QR, which is a statement that they gave us there on this on the statement there. And then we move now we've got the gradient. Now we can just say y is equals to mx plus c, and then we solve for the value of c by substituting y and x and also the gradient. So we can use any of these coordinates. So let's use q. Y of q is 3 is equals to m is negative 5/3, and then the x there is 6 plus c. Now substituting that, let's just punch it on the calculator. Negative 5/3 multiplied by 6, it gives us negative 10. And then we take that negative 10, we transpose it to the other side, it becomes 3 plus 10 equals c, and then c is equals to 13. So the equation is y is equals to negative 5/3x plus 13. So that means if you were to continue this line, it's going to cut the y-axis at 13. And then we move to the last one. And the last question says, determine with reasons the gradient of the line through T. And we already have the coordinates of T, and we found that they are 7/2 and 3/2. So they say the gradient of the line through T and the midpoint of PR. So we do not know the midpoint of PR. We have to find it. And then when we have those two, now we can find the gradient. So the midpoint, let's just say it's M of PQ, or PR rather, is equals to the x of P plus the x of R over 2, and y of P plus y of R, all that is over 2, and then it gives us the midpoint of PR as the x of P is 1 plus 9/2, and the y is 0 plus -2, all that is over 2. And then we find that the midpoint of PR is 10/2, which is 5, and 0 minus 2, -2/2 is -1. And then now we have to find the gradient of TM. So the gradient is equals to the y of M minus the y of T, all that is over the x of M minus the x of T. And the y of M is -1 minus 3/2, all that is over the x of M is 5 minus 7/2. So you just punch that on your calculator and you get the gradient of TM. So it's -1 minus 3/2, all that is over 5 minus 7/2, and we get -5/3. Now, as we can see, if this line has the gradient -5/3, that means this line is actually parallel to QR, as we can see. And then let's see if we do have another question here or we don't. Okay, I think that is that. So if you got it like this, you actually has Oh, you have gotten yourself 14.